Hey guys, welcome to chapter 7. Today we're going to begin a video lecture series on chemical reactions. So what we've done so far with this semester is we have looked at basic building blocks of an atom. So we looked at subatomic particles, protons, neutrons, electrons. We looked at how they come together to form atoms and elements. Then we started reacting those atoms together to form compounds and molecules. And now what we're going to look at is how different molecules come together to form a chemical reaction. So take two molecules, react them together, get something new. So we're just taking another step forward in this idea of chemistry. So the first thing we're going to talk about is chemical reactions. So just kind of getting some basic terminology out of the way, and then some steps on how to write and balance chemical reactions. And then in later videos, we're going to math with those chemical reactions. We're going to do something called stoichiometry. So that's where the chemical quantities piece comes in. But in this video, we're just going to introduce chemical reactions and how to balance them. So as you guys have probably realized, in chemistry, we symbolically represent pretty much everything. So let's look at a couple ways that we can symbolically represent chemical reactions. So here's two ways that we represent the exact same reaction. So we're just going to talk about some of the terminology, some of the words that I'm going to use throughout this chapter. So first things first, we see this reaction arrow right here. The reaction arrow is kind of like the equal sign in chemistry. Everything to the left of the reaction arrow is our reactant. So what are we reacting together? What are we mixing together? Everything on the right-hand side of the reaction arrow is our product. What are we producing? There's no rhyme or reason as to how many reactants or products that we can have. So here we see two reactants, one product. We could have three reactants, one product. One reactant, three products. So there's really any number of different combinations that you can have. So no rhyme or reason for that. Okay. So now that we know reactants, products, reaction arrow, we can look at the molecules themselves. So here we see a molecule of oxygen. So here's where those diatomic molecules are going to come back. So if I say I react hydrogen with oxygen, you automatically need to know that oxygen is a diatomic. So here we see oxygen. Diatomic oxygen has this subscript of a 2 here. So that subscript tells us about the identity of that molecule. So in O2, we've got 2 atoms of oxygen that are bound together. We see the same thing here with H2. So this subscript tells us about identity. It tells us that 2 hydrogen atoms are bound together. Coming over here to water, so H2O, same idea. 2 atoms of hydrogen, 1 atom of oxygen, all coming together to form this molecule. 1, 2 hydrogens, 1 oxygen. So these are our subscripts. We've seen them before. These big numbers in the front are called coefficients. And coefficients tell us about quantity. So I see this big coefficient of 2 in front of the hydrogen. That tells me that I have 2 of these molecules of hydrogen that are participating in this chemical reaction. And over here on the product side, I see a 2 in front of water. That tells me that 2 molecules of water are being produced out the other end. Coefficient for oxygen, so it's there. It's a coefficient of 1. But just like everything else in chemistry, 1 is typically implied. So again, if it makes sense to type or to write in the number 1, by all means do it. It's just typically implied. So again, we see that 1 molecule of oxygen. As we start balancing chemical reactions, it's important that we do not change the subscripts. So once we've identified what the molecule is and we put that down on paper, we cannot change those subscripts because then we would change the identity. When we're balancing these chemical equations, the only thing that we can change is this coefficient in the front. So coefficients are quantity. We're allowed to change those. Subscripts are identity. We can't touch them. Okay. So again, here's just another chemical equation for you. Just another look at reactants, products, reaction arrow. And here we've got 2 reactants, 2 products. Okay. Something else that you will see in your textbook, in your homework, are these letters that are in parentheses behind the molecules. So these letters just tell us about what state those molecules are in. So state, remember, solid, liquid, gas. So these letters tell us what state those different molecules are in. So here's our little table that helps us with those abbreviations. So if it's a G, that's in the gas state. So if we look at this chemical equation at the top, all of these molecules happen to be in the gas state. If you see an L in parentheses, that's going to identify the liquid state. If you see an S in parentheses, that would identify a solid. And then this guy right here, we'll see this a lot next chapter. That's an AQ. It stands for aqueous. So it's just really a shorthand way for chemists to write that it's dissolved in water. So let me just draw this out real quick since it's on the screen. So let's say I have a beaker of water here, and I take sodium chloride, and I drop it in this beaker of water. And then we've got sodium and chlorine that dissolves in this water, okay? Instead of writing this end product down here as NaCl plus H2O, because that's technically what's in the beaker, what we write is that NaCl is in aqueous form. So we say that NaCl is dissolved in the water. So just a little bit of a shorthand to let us know that whatever compound we have is dissolved in water. So that's what aqueous stands for. And you'll see that a lot next chapter. All right. So looking at this chemical equation, this is the same one that was on the previous slide. We notice something peculiar in this reaction, and I'll give you the punchline here. This reaction is not a balanced chemical reaction, so we'll have to do some work to balance it. But what I see here on the reactant side is that for this chemical reaction, we originally start out with 2 atoms of oxygen right here. And when I get over to the product side, the way that the reaction is written right now, we end with 3 atoms of oxygen. Well, that just can't happen. So when we undergo these chemical reactions, it's not that we just make new atoms. All we're doing is really just simply rearranging atoms. So we have to have the same number of oxygen atoms on the reactant side as we do on the product side. So that's one reason I know this is not a balanced chemical reaction. This is not how it happens. Again, same reaction, just looking at a different atom here. So same thing happens with our hydrogens. So we start with 4 hydrogens on the reactant side, and we only end with 2 reactions on the product side. So again, we can't just make atoms disappear. That's not how chemistry works. Remember, we're just rearranging what we have. So we need to have 4 atoms to start with, 4 atoms to end with. We have to have the same number on both sides of the reaction arrow. So what our job is to do as chemists is to balance chemical equations. Basically, what we're doing is we are predicting, without actually doing the experiment, we're predicting what types and how many molecules go into the reaction from a quantitative perspective. So without actually doing the experiment, we can predict, well, how many CH4s do we need in order for this reaction to take place? How many carbon dioxides do we get out on the other side? So we can predict that without actually doing it. Okay. So here is our unbalanced chemical equation that we've been looking at. So we're going to balance this together. The way that I'm about to show you is kind of like long division, right? So it's going to be a little bit tedious, a little bit time consuming, but I promise you I have not found any shortcuts when it comes to balancing chemical equations. So the way that you're going to see me do it in this presentation is the way that I still do it even after all these years of chemistry. So the first thing I do is I split my reaction into products and reactants. And I first just simply take inventory of what I have. So I want to see what's balanced, what's not. So the first atom I see is carbons, and I have one of those. Then I see the atom hydrogen, and I have 4 of those. Then I see oxygen, and I have 2 of those. Now I'm going to go to the product side of the arrow. I'm going to do the same thing. Just helpful hint here, even though the atoms show up in a different order, I would still put them in the same order, C, H, O, because you're going to bounce back and forth to balance these, and it's just easier if they're in the same line, okay? So carbons, I see 1 carbon on this side. Hydrogens, I have to come over here to water. I see 2 hydrogens. And then oxygens, be careful, a little bit tricky here. Whoops. I see 2 oxygens from carbon dioxide. And I see 1 oxygen from water for a total of 3 oxygens, okay? So we see oxygen showing up in 2 different molecules. So I kind of like to keep them separate and then have the total as well. It just helps me make sure that I don't miss something silly. Okay, so now we take an inventory. We can very easily see what's balanced, what's not. At this point, what we're going to do is add coefficients, and that's going to be the way that we predict what we think is happening. So I see 1 carbon, 1 carbon. That looks balanced, so I don't really need to touch that. Over here, I see that I put 4 hydrogens in, and as it's written right now, I only have 2 hydrogens coming out the other side. Well, I know that can't happen. So what can I do? What can I predict to get 4 hydrogens coming out? So what I'm going to do is I'm going to put a coefficient of 2 in front of the water. And what I'm doing by placing that 2 there is I'm saying, I think that 2 water molecules are produced, not just 1 water molecule. I think when this reaction goes to completion, it produces 2 molecules of water. Okay? So now that I have that coefficient of 2 there, and I have 2 molecules of water, I take coefficient times subscript. So 2 times 2, I would have 4 hydrogen atoms coming out the other side. That coefficient of 2 also affects another atom. What other atom does it affect? Yeah, the oxygen there, huh? Okay, so I still have 2 atoms of oxygen from carbon dioxide, but now I also have 2 atoms of oxygen from water. So again, coefficient times subscript, so 2 times 1 gives me 2. So that's going to interrupt my total. So 2 plus 2, I have 4 oxygen atoms. Okay. So carbons are balanced, check. Hydrogens are balanced, check. Oxygens are not. It says I start with 2 and I end with 4. Well, that can't happen. How do we just make up 2 atoms of oxygen? So what I'm going to do now is I'm going to predict that, you know what, it's probably not just 1 molecule of oxygen that reacts. I bet there's 2 molecules of oxygen that react during this chemical equation. So if 2 molecules of oxygen react with that 1 molecule of CH4, that means I start with coefficient times subscript 2 times 2. I start with 4. So now oxygens are balanced, and this is a balanced chemical equation. So the way that we would read this, or what we have predicted, is that 1 molecule of CH4 reacts with 2 molecules of oxygen. And when that happens, 1 molecule of carbon dioxide is formed and 2 molecules of water are formed. So now if we go and actually do this experiment, we'll see that those numbers would match up. That's exactly what happens. All right, so just showing you the same process in just a slightly different representation. So again, here's our unbalanced chemical reaction. So CH4 plus oxygen, carbon dioxide, and water. And if we count up the colored atoms here, we would see that they don't match up, okay? But after we balance that chemical reaction, we say 1 molecule of CH4 reacts with 2 molecules of oxygen to produce 1 molecule of carbon dioxide and 2 molecules of water. Now, if I go to count any of those colored dots, I would see that I have 1, 2, 3, 4 oxygens on the reactant side, 1, 2, 3, 4 oxygens on the product side. So this is a balanced chemical equation. Okay, so here's another example. Why don't you go ahead and pause the video, balance it, and then I'll work through it with you. All right, so first step is to take inventory of what we have. So I see silicon, 1, oxygen, 2, carbon, 1. I'm going to write the atoms in the same order on this side. And again, I see silicon, 1, oxygen, 1, and then carbon, I see 1 plus another 1, or a total of 2. Okay. Silicons are balanced, so 1 and 1, that's great. Oxygens are not, so we start with 2, we end with 1. We know that can't happen. So I'm going to predict that 2 molecules of carbon monoxide are formed. So if I think 2 molecules of carbon monoxide are formed, coefficient times subscript would mean that we end with 2 oxygen atoms. But what does that also affect? Yeah, it also affects this carbon. So we still have 1 from this first molecule, but this is now 2, and it's now a grand total of 3. So silicon, balanced. Oxygen, balanced. Carbon, 3 and 1, not balanced. So when we do this chemical reaction, we must have to start with 3 atoms of carbon. So I'm going to put a coefficient 3 here. So coefficient times subscript, 3 times 1 gives me 3. And now everything is balanced. Okay. So again, 1 molecule of silicon dioxide reacts with 3 atoms of carbon to produce 1 molecule and 2 molecules. So just some helpful hints as you guys are working through these. So I've given you some pretty simplistic examples. And as you guys start getting proficient and practicing, we're going to make them a little bit harder and harder. So here's some helpful hints as you get to the harder ones. So first, you're going to write a skeletal equation by writing correct chemical formulas. So there will be a time that instead of giving you the chemical reaction, I might give it to you in words, or by the end of this unit, you are also going to know, I think, 4 chemical reactions. So I'll give you the reactants and you'll know what products are produced. You'll be able to predict what happens. So when you guys get to those types of problems, the first thing you want to do is just make sure your chemical formulas are correct, that you're following all of the ionic rules, making sure they're electrically neutral, or that you wrote down the correct covalent compound, looking at their prefixes. So that's going to be the first thing. If you find yourself in this like endless cycle of trying to balance, I would stop and double check your chemical formulas because that's usually where the error happens. Next, once you start balancing, if an element occurs in only one compound on both sides of the equation, balance it first. So let me show you an example of this. Here, we balanced oxygen first. Why did I pick oxygen? Because oxygen is in one compound on the reactant side, one compound on the product side. So that made it pretty easy to balance first. And everything else shook out from there. If an element occurs as a free element or by itself on either side of the chemical equation, balance that last. So again, in this latest example, I wanted to save this carbon for last because it's by itself. It's the easiest to manipulate at the end. When I put that 3 in front of it, it didn't affect anything else. It just simply fixed the one problem I had left. So if you see these free elements or something like a diatomic, like O2 by itself, do those last because they're the easiest to manipulate at the end. Okay. And then you guys are going to start to get pretty proficient at these. You're going to start getting pretty fast, but it's always a good idea to just go back and double check to make sure everything's balanced on both sides. The one area that gets missed the most often are cases like this where it's in more than one place. So you get to working really fast and you forget that this changed to 2 instead of changing it to 4, something silly like that. So this is always the area that I see that gets missed the most. So it's always a good idea to just stop and double check your work. And then last thing is you never change, only change coefficients, never change subscripts. So once the chemical formulas are on the paper and they're correct, do not touch those subscripts. So for example, let's say I was trying to balance an equation with water, and instead of doing the coefficient, I said, oh, let me put a subscript here. Well, now I've completely changed the identity of that molecule. It's not water anymore. Now it's hydrogen peroxide. So that's why we can't change the subscripts, because that changes the identity. We can only change coefficients. So that's it for balancing chemical equations. Really, the only way to get good at this is to practice. So go out and find some practice sheets, do the homework. You'll start to see some difficult areas pop out. So just go practice, practice, practice. I hope you guys found this helpful.